Okay. So try to solve this question. Alright, let me write this question for you. Yeah, try to solve this question. You need to find the current. Okay. Question is, find the current in below given network. The diode is ideal. Okay. So this is your figure. You need to find the current. Okay. So this is this. So this is the figure. Means like you have 2 ohm resistor, and here it is 2 ohm resistor. This is positive negative 10 volt. But the thing is that you are getting one diode. Okay. This I current you have to find. And this is positive negative. It's 1 ohm, and this is your 3 ampere. Okay. So you need to find the value of current I, particular current I. So guys, how you will find this current? Means this is the equivalent figure, and you need to find the value of I. So how can you find this equivalent current? This is 2 ampere, this is 2 ampere. Okay. So let me tell you, for solving this question, there are lots of method. If you will study the analog, you can solve this question with the help of analog electronics. But here we are studying the Norton's theorem. We had studied Norton theorems and all. Okay. So this network is a linear or non-linear? It is non-linear network. Why so? Because diode is connected. This particular diode is connected. So diode is a non-linear element. So that's why this particular network is non-linear. Okay. I told you in a previous classes, the equivalent of this can be, make it like 10 divided by 2. How much current? 5 ampere current. And it will be parallel to 2 ohm. So this can be transformed like this, and this can be transformed like this. So we have particular this. So 10 divided by 2, how much current I will get? 5 ampere. Okay. And resistance will be parallel to plus 2 ohm. This is your 2 ohm. This is. And how can we transform this? We can transform this as a positive negative 3 volt series with 1 ohm resistor. Source transformation. So source means you have a R element here, and you have a positive negative E voltage. So you can transform this as a E by R current parallel with R resistor. And if you want to transfer this, so you have to multiply the current with resistor. You will get the voltage source, you will get the resistor source. So here we have voltage and resistor. So what will be the current? here we have a current and voltage. Current is there and resistor is there. So current, if current is multiplied with 1 ohm, we will get the potential 3, and that potential will be connected to the same resistor in a series. So we transform this particular circuit in this way. Okay. So here we can see now. Here we can see this 2 ohm and this 2 ohm are in series, are in parallel. So what will the equivalent? 1 ohm. 2 into 2.
1.
Yeah, 1. 2 into 2 divided by 4, you will get 1. And you are getting this as a 5 ampere. It's positive, negative. Positive, negative. This is 3 volt. This is 1 volt. So you can again transform this particular thing in positive, negative. 5 into 1, 5 volt you will get, parallel with the same resistor. 1 ohm. Positive, negative. 3. This is 1 ohm. This is 3 ohm. So what will be the current? Suppose I am assuming this diode is on. Diode is on. So if diode is on, this is the ideal diode. This is the ideal diode, means no voltage will be. So it will have a 0 voltage. So what will the current? So I will be 5 minus 3 divided by 2. So I is 1 ampere current will flow. Okay. Or you can see now, it's means it will be on. Why it will be on? Because it have a positive 5 volt here and 3 volt here, and here some current will develop. Means suppose we have I. Okay. And if you are taking positive, negative, V forward. So if I am assuming V forward, it's a conducting. So V forward will be 0 because it is ideal. But in a non-ideal case, the forward voltage will be, you have to assume 0.7. 0.7. The non-ideal cases. Okay. So that's why here it is ideal, and here positive voltage here means 5 minus 3 we are getting something positive. That means our diode is on. Although there will be some potential drop here also, but let it be. Means this diode is on. I am considering this diode. If this diode is off, then your current will be 0. Okay, but I am considering this diode is on. So this diode is on means it's a simple circuit like this. This particular is 0 volt across diode, and it is 1 ohm. It is 1 ohm, and you need to find the current in this particular. So I will be this 5 minus 3 divided by 2. So I will be 1 ampere. I hope you got it. Anyone? Any doubt is there, or is this clear? Okay. Let's move to the next question then, if it is clear. Question is, the network N consists of resistor and independent sources. Resistor and independent sources. Okay. When resistor R is 0 and 2 ohm, just wait. Yeah. And independent sources. Independent sources. Okay. When resistor R is 0 and 2 ohm, the current I is 3 ampere and 1.5 ampere respectively. Okay. You need to find the current I when resistor R is 1 ohm. So a network can consist of a resistor, okay, and independent sources. So suppose you have a network like this. This is your network, and this is your resistor R. So figure is given like this. Okay. So how you will solve this question? This network means it will have some VTH and it will have some RTH, Thevenins. So this network can be placed like this: VTH, RTH, and you have R, and the current is I. Okay, so what the equation you will get? VTH equation. VTH is equals to I into RTH plus R. Okay, so what is the value of I? Current when resistor is 0 is 3 ampere. So 3 RTH. You are getting equation 1. And what is the equation of VTH when current will when resistor is 2 ohm? So 1.5 ampere current you are getting. 1.5 ampere RTH plus 2. This is equation 2. Solve this equation 1 and equation 2 and get the result. So by equation 1 and 2, 3 RTH is equals to 1.5 RTH plus 3. It will be 2 RTH. No, 1.5 RTH. 1.5 RTH. RTH value will be 3 divided by 1.5. So RTH value you got as a 2 ohm. What will the value of a VTH then? Substitute in equation 1. VTH is equals to 3 into 2. It will be 6 volt. Now what they had asked, you got the value of a VTH, that is 6 volt. You got the value of a RTH, that is 2 ohm. And they had asked the current when your R is 1. So what? How much current will get? 6 volt divided by 3. 2 ampere. Is this clear to everyone? Prasanna?
One second.
See, what I am telling, the network consists of a resistor and independent sources. So this is my network. Okay. So in this network some resistor will be there like this, like this. So this can be replaced like one equivalent RTH and equivalent voltage VTH. So that I had mentioned what this network can be make it like this. Okay, and some load is connected, that R is my load. So what they in the questions what they had said, VTH, the value of a VTH and RTH will be remain constant for any value of anything. So what I am saying, VTH is equals to, if I'll apply the KVL, I will get VTH is equals to I RTH plus R. In the question itself they had given R is 0. When R is 0, when your this load value R resistance is 0, you are getting a current of 3 ampere. So I get the equation VTH is equals to 3 into RTH. And again what they had said, when R is 2 ohm, you will get the current of a 1.5 ampere. Okay. Now by using this equation 1 and equation 2, you will get the value of a VTH and RTH. So VTH value I am getting 6 volt and RTH value I am getting 2 volt. 2 ohm. So I just, this is my VTH value and this particular is my RTH value. And what they had asked, when your load current will be how much when resistor is 1 ohm. So I am just making my resistor as a 1 ohm and I am calculating the value of I. I will get the value of I as a 2 ampere. Now it's clear?
Yeah, okay.
Okay. You have one question, and the question is, develop the Thevenin's and the Norton equivalent circuit. Develop the Thevenin Thevenins and Norton equivalent equivalent circuit across the terminal A and B. So you have a question. This is your positive, this is your voltage source, positive, negative. This is 20 volt. This particular is 5 ohm. This is 10 ampere, and this is your A, this particular is B. So you need to find the Thevenins and Norton both. So let's find the Thevenin's equivalent circuit first. So if you'll go for the Thevenin's equivalent circuit, what we do for Thevenin's equivalent circuit? We opened it, means this is my VTH. This particular is my VTH. So it's open only. Current is coming 0. Okay, so 10 ampere current will flow and this only. This VTH, this, if I'll take this particular VTH, so this will be my VTH only. Okay. This particular will be my VTH. And the value of a VTH is 20 volt directly. See, it's given 20 volt, it's coming across this. So what will the value of a VTH? It's 20 volt directly, we are seeing now. If you are taking this as a 0, if you are assuming that VAB is your VTH, this voltage particular is your VTH, so it will be parallel. So it will be parallel to this. So we are getting the value of a VTH directly 20 volt. Okay. So for finding the value of a RTH, what you need to do? What you need to do for finding the value of a RTH? You need to short circuit. So this will be shorted. These things will be shorted and this will get open. Current will get open. So guys, you are getting and this is your RTH. So shorted means what? This R value is 0. So what is the value of RTH in this particular diagram? It will be 0, because if you will apply the voltage here, the current will directly jump from this side. It will not come in this 5 ohm. And even if you will multiply, just give me a second, guys, just give me a second. So what I am telling means you have a R value is a 0 and this is your 5 ohm. So if even means you will do the parallel, you will get the 0 into 5 divided by 0 plus 5, then RTH is coming 0. Okay. So what is the VTH you are getting? Positive, negative, 20 volt, and this is your 0 ohm. This is your Thevenin's equivalent. And for finding the Thevenin's equivalent, Norton equivalents, you can directly transform this circuit by using the source transformation. So what will the current will come? Current will be V by R. So this is 20 volt, this is 0. So what current you will get? 20 divided by 0. It is infinite. So we are getting a infinite current. And what is the resistance? It's shorted. R0 means it's a shorted only. So Norton equivalent will be like this. So we cannot say Norton equivalent will be not applicable. We cannot make a Norton equivalent circuit for this circuit. Okay, whenever you are getting the RTH value as a 0, so for that value you cannot make your Norton equivalent circuit. Okay, because you are getting the circuit like this, so this is irrelevant circuit. So for the above given network, we cannot develop the Norton equation because it is not satisfying KVL. This is your irrelevant circuit. So we cannot develop the, okay. So Norton equivalent will not be developed in this circuit. This was the concept. And you have one question like this. Uh, Develop a Norton and Thevenin's equivalent circuit. So you have to develop Norton and Thevenin equation, okay, for the given network. So you have a network like this. This is your positive negative. This particular is your current 1 ampere. This is your 2 ohm. This is your 5 volt. So guys, let's first develop the Norton equivalent circuit. So if you will develop the Norton, this is your A, this particular is your B. So for developing the Norton equivalent circuit, what we do? Short circuit. This is my IN. So I am getting the IN value is how much? Directly I am getting the IN value 1 ampere. So I know the value of 1 ampere. Okay, what about the current? So what about the register? For finding the register, what you have to do? By seeing this, voltage will be shorted, R will be there, and current will get opened. So we will get circuit like this. So what is the R equivalent? Infinite, because it is open. This will get open, na? This is a current source, that's why it's get open, and this will get short circuited. So if it will get open, the circuit will be like this, something like this. So what is the R equivalent? Infinite. So how much your equivalent Norton will be? Like how much? 1 ampere, and you are getting some R is equals to infinite. Okay, so we develop the Norton equivalent. What about the Thevenins? For Thevenins, for converting this into Thevenins, just multiply it into this 1 into infinite. V is equals to I into R. So you are getting infinite voltage, and you are getting the open circuit like this, means this is your R is infinite. So this kind of a circuit is irrelevant. So we cannot develop Thevenin's equivalent in this circuit. Whenever you are getting a voltage source and current source in a series, in that circuit you cannot develop the Thevenin's equivalent like this circuit. Okay, but you can develop the Norton equivalent. So Norton equivalent we can develop, but Thevenin's is not possible in this circuit. Okay, got it everyone? Vaishnavi, for you it's clear? Priyanka, for you? Prasanna?
Yeah.
So guys, One last question. This is the last question for, and we will start the next topic, that is reciprocity theorem. So you need to find the current. Okay. So write the question. Find the current flowing through 5 ohm resistor connected across the terminal of network given below. Okay, now they had given the network like this. Okay, they had given a graph like this. This is your voltage, this particular is your I, and they had mentioned like this: minus 4 ampere, this is 20 volt, and this is I, and this particular plus minus V. Okay guys, so what is the equations of this? Y is equals to mx plus c.
mx plus
What is your y? I. And what is your x? V. And what is the c point? C point is how much? Minus 4. Okay, minus 4. It's cutting to minus 4 point. So what is the slope? Slope m is y2 minus y1 divided by x2 minus x1. So my y2 is, okay, it's starting from here, y2 minus y1 divided by x2 minus x1. So y2 is how much? Y2 is, and you can directly even you can write like this also: equation by x by a plus y by b is equals to 1. So your x is v, y is I. Interceptions point of a x means v interception is at 20 and I interception at minus 4 is equals to 1. You will get the equations from this also. Minus 4, solve it and get the results. So 20 v minus 5 is equals to 20. So v is equals to 20 plus 5. So you can do like this also, it's up to you. But while applying in this also you will get the result. So y2 is this point is going from here to here, so y2 is 0. Okay, 0 minus of minus 4 divided by x2 was 0, x2 is 20 and x1 was 0. 20 minus 0, so we are getting 4 by 5 m value. We will put the m value in this. We will get I is equals to 4 by 5 v minus 4. So I is equals to 4v minus 20. So we are getting the 4v value as 20 plus I. See, this will become 5 na. 5 5 5 5 5. See,
sir.
yeah.
M is 4 by 20, sir.
Oh, 4 by 20. Okay, I did some mistake then. Yeah, it's 4 by 20. You will get the equation, same equations. It's up to you how you are solving. So means You have to use this equation, or you can use this particular equation and get the answer. Means you are getting the value v is equals to 5I plus 20. Okay guys, can anyone tell me what will be the value of v when I is 0? When your I will be 0, then what will be the value of v? See the equation. When your
20.
when I is 0, what is the value of a v? V value is 20, right? So v value we are getting, v value you are getting 20 volt. And what about when your I is -4? When your I is -4, then what is your v? It's 0.
0.
By seeing this only we can say na. So this network can be replaced like this: positive, negative. This is your VTH, this is your RTH, this. Okay. So VTH is what? VOC, open circuit. Open circuit means we are developing means you have some particular network. If they are asking you find the value of a VTH, so what we do, we just do open it. So open circuit means we know the value of a VTH. We know the value of a VTH is how much? 20. And ISC means in a Norton equivalent, what we do? Norton equivalent, we do the short circuit. So this is your IN, and IN current is given, and for the Norton equivalent, what is the voltage? Voltage we are getting the 0 volt. See the terminal voltage. So ISC is given you as a -4 ampere. And what about resistor? RTH. RTH is nothing but RTH is the ratio of these two voltage, VTH by ISC. So how much you will get? 20 divided by -4, -5. Okay. So, and one thing is also your resistor cannot be in a negative. So here in this question, here in this particular question, they had mentioned the I value in this way, and you are taking your IN network in this way. If you want to develop your IN is inverse of this, means opposite to this -I. So my ISC will be +4, because ISC is just opposite to -I. So that's why it will be +4. 20 divided by 4. So now we know the value. We know the value of a VOC, that is 20. We know the value of a RTH, that is 5. And what they had asked, when the current flowing through a 5 ohm resistor. So when we connect one 5 ohm resistor in this particular circuit, what will be the current flow? 20 divided by 10, that is 2 ampere. So answer will be 2 ampere. See, I will tell you once again, this is a very not too much difficult. See, here, just see this part. Here they had given you a circuit like this, means equations they had given. This particular is your equation. So in equations they had mentioned some current I is there, some V is there, and the current directions of a I is mentioned. It is mentioned in this. Okay, if you are finding the Norton equivalent current, what you do? Norton equivalent current is in this direction, so IN is minus of I. By seeing this circuit, you have to form the equation either by using y is equals to mx plus c, or you can use this equation: x by a plus y by b is equals to 1. The cutting point of A is x at 20 volt, and the cutting point of B is at -4. So using this you will get V minus 5 is equals to 20. And if you will use this y2 minus y1 divided by x2 minus x1, you will get 4 by 20, that is 1 by that is 1 by 5. Okay, and substitute this in this particular equation. I is equals to 1 by 5 v minus 4. So I is equals to v minus 20 into 5i. So you will get the same equations. V is equals to 5i plus 20. We are getting the same equation. See, this equation and this equation both are same. So you can use this or this, it's up to you. So now I got the value of, and replace this v, this particular v they had yeah, this particular v will be this. Okay, so now you have v is equals to 5i plus 20. Now what I am saying, you need to find the VOC. VOC will be always equal to V Thevenins across the point. So if you will make VOC, means your I is 0. So VOC value you are getting 20. So that is your VTH value. And for finding the Norton equivalent current, your voltage will be 0. Your VOC voltage will be 0. This is 0. This is 5i plus 20. Okay, so I we are getting minus 4. But we don't need this I. We need IN, not an equivalent current we need. So we know the relations. Not an equivalent current will be in these directions, and particular current is given in this direction. So IN is opposite to I. So IN will be minus I. So IN we are getting as a 4. So you have the Thevenin's voltage that is 20, and you have ISC or ISC, you can say either ISC or I Norton, that is 4. And the ratio of a Thevenin's voltage and the Norton current will give you RTH. 20 divided by 4, you are getting 5 ohm. So your equivalent circuit will be how much? Your equivalent circuit will be, this is your 5 ohm. This particular is my Thevenin's voltage, VTH. Now they had asked what will be the current flowing through 5 ohm resistor. So 5 ohm resistor means you are connecting 5 ohm to the terminal. So this was my terminal. So I am connecting this as a 5 ohm. And you have a VTH value that is 20. So you are getting I current is 20 divided by 10. It is 2 ampere. Is this clear? Priyanka, is this clear? Sharon, is this clear?
Yes, sir.
Prasanna, for you? Is this clear?
Yeah.
Okay. So now we'll move to the next topic, that is reciprocity theorem. This is our fourth topic in theorem. Reciprocity theorem. So what is the meaning of a reciprocity theorem? So suppose, write it down directly. In linear bilateral signal source network, in linear bilateral signal source network, the ratio of response to excitation. Excitation means our voltage, what the input voltage we are giving, remain same even when even when their positions are their positions are interchanged. So in a linear bilateral signal source network, the ratio of response to excitations remains same even when their positions are interchanged. Okay. So I will tell you in a better way by diagram. First write this statement. Other words, in other words, in any linear bilateral network, if a signal voltage, if a signal voltage source Vx, voltage source, if a signal voltage source V of x source V of x, this is source V of x. Okay. In branch x produces the current response Iy. Okay, current response Iy in branch y, in particular branch y. Then the removal the voltage source from branch x, then the removal voltage from branch x, okay, then the removal voltage branch x and its insertion in the branch y, will produce the same current Iy in branch y. So what is the meaning? Okay. Okay, suppose you have a network like this. Okay, you have a network like this. Now this is your particular branch, this is your Vx, and this particular you have some Iy current. Okay, so if I will remove these things and if I'll put these things in this branch, okay, reciprocity, if I am putting this particular V of x in this branch, okay, so I am interchanging and this I am bringing this side, my Iy. So if I will insert these things in this part, I will get the same current what was producing here. So this is the meaning of reciprocity. Okay, we'll do the question, we'll understand in a very, very good way. See, you have understood like this. You have a network Okay, you have particular voltage, positive, negative, V of x, and you have IY current. Okay, so and now what you did, you change this voltage to this particular side, positive, negative, V of x. So you will, what you will see now, you will get the same current what was producing here. You will get the same current what was producing here, that is IY. The meaning of this in a simple way is this only. So we had interchanged the branch. So this branch current, what was producing in this particular side, it will automatically will get the same current and this. Okay. So write a question, means like in a question you will understood. Suppose you need to find the current. Okay, question is find the current I when the network N is following the reciprocity condition. The network N is following the reciprocity condition. Reciprocity condition. This is your network. So here positive, negative, 10 volt. Okay, and here it is given this as a 2 ampere. Okay, it's 2 ampere. So now they had asked you what now? They had asked you what will be the current in this I if the voltage across this is 30 volt. So guys, what will the current in this? Any guess? See, reciprocity theorem means response by excitation will always be same. So which is our response? This output will be response. And what is the excitation? This is our excitation. So write the means in a circuit 1, the ratio of in a particular network, the response to excitation ratio will always same. Response to excitation ratio will always same. So what is the response value we are getting? 2 ampere. What is the excitation value we are getting? 10 volt. What is the response in this particular network? What is the response and what is the excitation? So this means we are assuming this is our excitation and we are assuming this is our response. The voltage part will be excitation. So response is I and excitation is 30. So you are getting I is equals to 6 ampere. Okay, means how much voltage you are applying, that is your excitation, and what the current you are getting, that is your response. So we are getting the 6 ampere. Or you can even do in a this way also. So this is a linear network, linear bilateral network. Okay, linear bilateral network. So what the voltage is present is in this side, 30 volt. So make it 30. How can you make it 30? Multiply it by 3. So this is network and you will get positive, negative, 30. And what the current you are getting? This as a 3 into 2, 6 ampere current. Now change the position, because if you will change this 30 position, the same current will flow in this part. according to reciprocity theorem. Positive, negative, 30 volt, you will get the same current, 6 ampere. So what is the current? We are getting 6 ampere. Prasanna, is this clear?
Yeah.
Okay, if it is clear, then solve this question. You need to find the value of a current when the network follow the reciprocity condition. Okay, so question is, network is following the reciprocity condition. I am not writing the question. Your question is this is your network, and in this particular network it is given that is 10 volt, and that is 5 ampere, and it's given this is a 2 ampere. Okay, now you have a conditions like this. Network is here, this is your plus minus 30 volt, and you need to find the value of I and the direction, see the direction. And here it is also given plus minus 30 volt. So how you will solve this question? How you will solve this particular question? Okay, first make this at as 30. So if you want to make it as a 30, you have to multiply it with 3. This will be the network. So you are getting positive, negative, 30 volt,
30 volt,
15 ampere,
50,
and
and
6 ampere.
6.
Okay, now what you need to do? Just reverse, means do the reverse things. Change the excitation position. Positive, negative, 30 volt, and the current will come here as a 6 ampere, and the current here will be 15 ampere. Add this. You will get positive, negative, 30 volt. This will be positive, negative, 30. What about the current? One current is in this side and one current is in this side. You need to find the current in this side. So 6 ampere current flowing. Okay, you will take 6 ampere current minus 15 ampere current, because so you will get the current will be minus 7 ampere. Oh, not 6 minus, it will be minus 9, na? Minus 9 ampere.
9.
Yeah, minus 9. Understood how we did it?
Oh,
And if anyone will ask you what will the current in this particular direction, then this is 15, and the same 6 ampere is flowing in this. So 15 plus 6 is 21.
21.
So we can play like this with this kind of a network. Okay. Now
So just give 1 minute, we'll copy that and we'll do.
1 minute.
Oh, we'll copy that problem.
Okay, copy it.
Sir, you can continue.
Okay. So the same means the same concept. So two question is there. Then we'll start the another theorem. Uh, you need to find the value of a current. Okay. This is your network. Okay. And in this particular network, you are having a voltage 10 volt, and this is your 5 ampere. You are getting the current here, it is 2 ampere. And suppose this is your network and you are getting 4 ohm, this is I, and this particular positive negative 30 volt. So you need to find the value of I. How you will find? First, what you will do? Make it as a 30. So I multiply it by 30, means 3. You will get 15. This will be positive negative 30. This will be 6 ampere. Okay. So we need 30 this side. So okay, bring 30 here. This is my 30 volt. And we have something you can say 6 ampere this side. But in the question you just check it. So here you are getting a 4 ohm, right? This particular is a
Resistor.
4 ohm resistor, but here there is a no resistor. So how you will make these things? How you will make these things as a 4 ohm resistor? Okay, we can do like this also, no? Okay, see, we can make this circuit like this, no? Positive negative 4I. We can remove this resistor and make it like this 4I, 4 into I as a voltage. This is your network. This particular you are getting positive negative 30 volt. This is I. Okay, but do you think if we'll do like this we'll get the answer? We'll get the answer, do you think, if we'll do like this? No, we will not get the answer if we'll do like this also. So we can do one thing. What we can do, we can use the Thevenin's theorem here. Okay, we are assuming we have some network. Here voltage is 30 volt and we are getting the current I is that particular means okay. So this particular I branch current you are getting, this particular I you are getting 6 ohm. Okay, so these things we know, but we need to find the current across this 4 ohm, so yeah, so we need to find the RTH value, Thevenin's value across this. If I am seeing from this point, if I am seeing if I had opened suppose if I had opened this branch, I just opened this branch, I need to know the what is the VTH value across this particular thing, what will the VTH value will come, what will the RTH value will come. Okay, we need to know this thing. So how can we do this particular thing? And you can do also one thing. Suppose it will be very good. Here we have a current. Okay, we know this current, that is
6
6 ampere.
ampere.
So 6 ampere. Okay, if it is a 6 ampere, we know the short circuit current ISC, means Norton current we know, IN current we know, 6 ampere. Okay, okay. What about the voltage? ISC we know, ISC is 6 ampere. 6 ampere we know. What about your RN? RN value will be how much? Means if you want to find the value of RN. So for finding the value of RN, what we do for finding the value of RN? All the voltage source will become short circuit, right? All the voltage source will become short circuit. So for finding the value of RN, here you have I value is how much? 15.
15.
What is 30 divided by 15?
2.
So your RN value is 2 directly. So we got the value of IN, that is 6 ampere. We got the value of RN, that is 2, and we need to find the value of I when it will be connected to 4 ohm. This current you need to find. So this will be positive negative 12, and this will be 2, and this will be 4. So how much current you will get? 12 divided by 6, 2 ampere. Or guys, means in a very simple way, I will explain these things once again. See, your question is, you have a question, this is your network, this particular is your 5 ampere, this is your positive negative 10 volt, and it's given it as a 2 ampere. Okay, and what they had asked, this is your network, you have positive negative 30, and this is R, that is the R value is 4 ohm, and you need to find the value of I across this. So means how can we solve this question? First you need to simply make the circuit like this. So if you make the circuit
Multiply the first network with
multiplied by 3, so you will get network, you multiplied 3 and you made the circuit like this. Okay, so it will be positive negative 30 this side, current will be 15 ampere, this will be your 15 ampere, and this you are getting as a 6 ampere. So this part is clear to everyone, how we are getting these things?
yeah.
We are multiplying 3 everywhere, we just change the position by reciprocity. So this part I hope it's clear to everyone. Okay guys, I just want to tell you one thing, means you need to find the value of R equivalent, Rn value you need to find. Okay, Rn value means a network value, we need to find the resistance value. So suppose whatever the things, means this is my huge circuit. This is my huge circuit. If I know the current and if I know the voltage, if I simply divide this particular voltage to this particular current, I will get the R value, 10 divided by 5. I will get the R equivalent from this point. If I want to see from this point, 10 divided by 5, R equivalent is coming how much? 2 ohm. This is my huge network, I am assuming. But I know the value of voltage and I know the value of a current. So if I'll divide this, I will get the value of resistor, right? RTH value, I will get it now. Okay. So you, from where you are watching, from this point only you need to solve the circuit. From this point you need to solve the circuit. And for finding the R equivalent and all, we do the short circuit, and means the Thevenin's part will be the short circuit. Even you will, if you want to find the value of R, you can do 30 divided by 15, or you can do 10 divided by 5. Okay, so I have to see from this point, then only I am doing this particular 10 divided by this 5. So I am getting 2 ohm, and I know the value of that is IN, my ISC value, short circuited value. So I got a network like this, means this is my ISC, this is my RN, 2 ohm, and this particular, but I know, I want to know the current when I will connect one resistor. So this resistor I had connected in this, and the value of this resistor as a 4 ohm. Now I simply, means ISC value I know 6 ampere. So I just do the source transformation, or you can do directly like this by current division rule also. So you need to find the value of this particular current in a 4 ohm resistor current. So what will be the 6 into 2 divided by 4 plus 2, 6. So this you will get 2 ampere. Is this clear, Prasanna?
Yeah.
Okay. If this thing is clear, then one question is like that only. Question is, you have a network, okay, this is 5 ampere, this particular is positive, negative, 10 volt, and here it is given this as a positive, negative, it's open, and it's given a 4 volt, and you have a network like this. You have a 6 ohm, this is 6 ohm, this particular I you need to find when you have a current of 10 ampere. So how you will do it, and how you will get the value of this particular thing, network? You have to solve like this. So see the solution. So across this you need, so that's why I just want to get the value. I'm making this as a open, so this is my VTH, okay, and this particular is my some I current, that is I will be 0 if I'm making this as a VTH, and this is my current is given as a 10 ampere, okay. So response means in a network, in any network, means in the same kind of network, what is the response here? Excitation here, VTH, and what is the response you are getting? In this direction, current is in this direction, okay. So VTH by 10 ampere. If you will see the first one, what is the response? What is the response you are seeing? What is the what is the
Four.
yeah, what is the excitation? That is your 4 volt. And what is the response you are getting? 5.
Five.
So what is the value you will get? VTH value you will get 8 volt. Correct? Correct? Or you can do like this. By this way also you can do. Or what currents you are getting here? What currents you are getting here? 10. Means you need to get the 10 ampere current na. You need to get the 10 ampere current na. Just see, you need to make 5 ampere current as a 10 ampere current, right?
Multiply into two.
If you multiply it with the 2 also, so and just change the position, so what you will get? This will be positive negative 20,
20.
and this will
10
be
ampere.
10 ampere, right? And what it will become? Positive negative 8.
8.
So this particular network can be make like this also. We can represent these things like this: positive negative, and here 10 ampere current is flowing.
10.
That is 20 volt, and that is our positive negative 8. So this is positive negative 8, means I got the value of a VTH as a 8 volt, and I have to take the resistance value across these positions, so what is the RTH value? 10 divided by 5, 2. So you know the positive negative 8 volt, you know the RTH value as a 2 ohm, and you need to know the current across 6 ohm resistor. So that's why you will connect 6 ohm resistor. So what is the current? 8 divided by 8, 1 ampere. I hope you got it. Prasanna, you got it or not?
Yeah, I got it.
So we just put the, means what is the resistance across, means if I am seeing from this point, even if you want to see the resistance from this point also, you have a 20 volt divided by, you have a current 10 ampere, divide 20 volt with 10 ampere, you will get the same resistance, 20 divided by 10. So anyway, so that is our R equivalent. Okay, so this was the story of reciprocity. Anyone is having any doubt, they can ask, or we'll move to the next topic. Priyanka, Sharon, Prasanna, Guna, anyone?
Yes.
Everything is clear? We can go for the next topic then. Okay.
Okay.
Write the next topic, that is Milliman's theorem. Fifth topic is Milliman's theorem. Millman's. Okay, suppose you have a network like this, positive negative E1, this is R1, this particular is positive negative E2, that is R2. It's going like this up infinitely. It is have Rn, and this positive negative En. So we can make this circuit equivalent circuit, VTH circuit, means a Thevenin's equivalent circuit, like some RTH divided by some positive negative, I am writing ETH, that is your VTH. Correct? Any network can be replaced like this. Okay, by seeing this point, means I am extending this point. This is your ETH, this particular. So how you will do it? What is the source transformation of this? current will become E1 by R1, and this will be R1. Correct? What is the source transformation of this? Current will become E2 by R2. One resistor will come parallel to this. So this circuit will go like this. En by Rn, you will get some resistance Rn. Okay guys, so you can, now all the things are in parallel, so you can make the circuit like this, 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 and your resistance means it's dotted, and your resistance is connected like this, it's dotted up to this. So you are getting the value like E1 by R1, E2 by R2, E3 by R3. Okay, that is dotted, means many value will come. So up to En by Rn you will get. Okay, this will be En by Rn. En by Rn. This is R1, this is R2, this is R3 dot 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 Rn. Okay, so this all particular current can be replaced like this as a single current. The all are the summation na, it's going this all are getting added, so it's all are summation current only. So it is what, E1 by R1 plus E2 by R2 plus E3 by R3 plus dot 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 En by Rn, and your all resistance are parallel connection. So 1 by R1 plus 1 by R2 plus 1 by R3 dot 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 1 by Rn inverse. Okay, so what is the Rn value you are getting? 1 divided by 1 by R1 plus 1 by R2 plus dot 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 1 by Rn. And what is the In value you are getting? E1 by R1 plus E2 by R2 plus E3 by R3 plus dot 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 En by Rn. And now circuit you got like this, In value into Rn value. This is your Norton equivalent circuit. If you want to make this Norton equivalent circuit into Thevenin's equivalent circuit, what you have to do? This will be your Rn, and this both will get, this will be En. En will be In into Rn. So you can make the circuit like this. So what is the equations of a E you will get? En you will get. En will be En into Rn. In value will be E1 by R1 plus E2 by R2 dot 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 En by Rn. And what is the Rn value you got? Rn value you got 1 by this particular, so it will come downside. So 1 by R1 plus 1 by R2 plus dot 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 1 by Rn. Okay, so what is the E value? We can write it like this: summation I is equals to 1 to n EI into GI. G means 1 by R divided by summation I is equals to 1 to n 1 by Rn. 1 by R1 means 1 by R1 means G1, 1 by R2 means G2. So directly I am writing summation GI. So that means this meaning this E1 by R1 plus E2 by R2 plus dot 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 En by Rn. We can make like this. So this is nothing but this is your Millman's theorem. This was the Millman's theorem. Okay, now suppose is this clear to everyone? Prasanna, is this clear?
Yes, sir.
See,
Yes, sir.
it's very easy, na? It's not tough. If we have a voltage source and resistor, if we have a voltage source and resistor, so we can make the voltage source and resistor in the current source parallel with resistor. So we make it like this. So all currents are coming like this and all resistors are coming like this. So the summation of all current will be a single current. That's why I added a all, and all the resistance are parallel. So this is my parallel resistance. So the Rn value will be 1 by R1 plus 1 by R2 plus 1 by Rn. So this is nothing but this can be written as 1 divided by summation of gi. I is equals to 1 to n. Means if you will put what you will get, g1, g2 dot 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 up to gn. 1 by g1 is what? 1 by r1. g2 is 1 by r2. 1 by rn. Okay, same things that your e1 by r1 plus e2 by r2, it's what it is, e1 g1, e2 g2, en gn. So in the summation form you can write like this, na? I is equals to 1 to n ei into gi, and this is your in value, and you have the in value, and you have the rn value. You have the in value, you have the rn value. So en will be in into rn and rn will be rn. So en will be in into rn. So in into rn value you are getting like this. In value was summation ei gi, I is equals to 1 to n, and your rn value was summation I is equals to 1 to n gi. This is just a Millman's theorem. Same thing we do for, like you have a network. Suppose you have a network like this. This is your I1. This particular branch current is your R1. It's going like this only. Okay, this is your R2. This is your I2. It's going like this. This is your IN and it is RN. Okay, same can be, we can make the same circuit like this as a Norton theorems. One is my R and one is my I. So this is my circuit. Okay, we can make this circuit like this. How so? Use the source transformation. So if you use the source transformation, what will the equivalent of this? I1 into R1, R1, I2 into R2, R2, it will go like this. IN into RN, RN. Okay. So what is the, we got the circuit like this. So what will be the overall, your capital E will be this plus this plus this, overall resistance, overall voltages plus. So I1 R1 plus I2 R2 plus dot 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 IN RN. And what is the equivalent resistance? All are in series. So R will be R1 plus R2 dot 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 RN. We can write these things as a summation I into R. I is equals to 1 to n, and we can write these things in summation I is equals to 1 to n R I. So now we have negative positive, that is my E, and this is my capital R. If you want to make these things in the form of current source and voltage source, so this is my current and this will become my R. So what is I? I is nothing but E by R. and R will be R only. So what the I value you are getting? R value you are getting summation I is equals to 1 to n I into Ri divided by summation Ri is equals to 1 to n. Guys, is this clear? Prasanna, you understood? Understood the way what we are doing. I1 is here, R1 is here, I2 is here, R2 is here. This can be transformed like in this way. So this is my one voltage, this is my another voltage. All are in series. So the net voltage will be the summations of this. So that's why I1, R1, I2, R2, IN, Rn we are getting. In the these huge equations we can write in like this with the help of summation. I is equals to 1 to n, I into Ri. And all the resistors are in series. So we can make it like this. So the meaning of this is what? We are getting a equivalent voltage, equivalent resistance. Now we want to convert this equivalent voltage and equivalent resistance in the form of current and resistor. So we will do the transformation. So E by R will be our I and R will be R. So E, that is capital E, is EI into R I. Summation I is equals to 1 to n. Summation I is equals to 1 to n. That is our Ri. Understood?
Yeah.
Present. So now it's a very easy. So this was the Milliman's theorem only. Yeah. So now you have to find. Suppose question is R1 positive negative V1, R2 positive negative V2, R3 positive negative V3. So guys, you need to form your VTH and your RTH. So what will the answer for this? VTH will be summation of I is equals to
V by R.
yeah, E by R. So that is, we can write like this also, na?
V1 by R1 plus V2 by R2.
Hmm.
So understood.
Yeah,
I
we can write like this. Okay, you are saying correct.
I2, I equal to 1 to
We
3.
can write like this: VI into GI summation I is
Yeah.
equals to 1 to
1 to
n, and R1 was R1, our net equivalent was GI summation I is
G.
equals to 1 to n. So what is the what we'll get? So here the n value is 3. 1 2 3. Okay, Vi into Gi, that is summation I is equals to 1 to 3, and this is Gi. So what you will get? V1 by R1 plus V2 by R2 plus V3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. Okay, and suppose your R1, R2, R3 values are given. R1, R2, R3 value is capital R. So what you will get? V1 plus V2 plus V3 1 by R divided by 3 by R. So VTH value is coming as V1 plus V2 plus 3 by 3. So you are getting V1 plus V2 plus V3 by 3, and RTH value will be how much? RTH value will be 1 by R1 plus 1 by R2 plus 1 by R3 inverse. So this is 3 by R inverse. So it is R by 3. So it is R by 3. Understood, guys? And suppose we are getting here, and suppose V1 is equals to V2 is equals to V3 is equals to V, then VTH value will be 3V by 3. You will get V. Understood? If you guys understood, Prasanna understood? Priyanka, understood?
Yes, sir.
For you, Sharon, it's understood or not? Guna? Okay. So, see, now you have a question. You have a circuit like this. 2, positive, negative, this is 2 volt. Positive, negative, this is 4 volt. This is 4. Positive, negative, this is 16 volt. This is, okay, I will write this 4. Okay, this is 2, or just wait. Just wait. This is positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. 2 volt, 4 volt, 8 volt, 16 volt, 32 volt. It's given 2 ohm. It's given 4 ohm. It's given 16 ohm, and this is your this particular is 32 ohm, and this is your 64 ohm. So 2, 4, okay, I just missed one point. 2, 4, this is 8, this is 16, this is 32 ohm, and here it is given as 64 ohm. You need to find the value of I. So guys, how you will do it? You need to find the value of I. So how you will do it? So see, this particular network, we can use Milliman's theorem, right? This particular is your Milliman's theorem only, na? So what is the VTH you will get? Overall VTH, summation of
Summation of V by R by summation of 1 by R.
so I is equals to 1 to how many branches there? 1, 2, 3, 4, 5 branch.
5.
V into I into GI.
V into GI by
Summation of I is equals to 1 to 5
145
GI.
GI.
So okay, do the calculation and tell me, means 2 into 2 inverse plus 4
P by
into
2.
4 inverse plus 8 into 8 inverse plus 16 into 16 inverse plus 32 into 32 inverse divided by 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32. So this is 2 into 2 inverse is what? 1. 4 into 4 inverse is
1.
what? 1. So how much you will get?
All will be 5.
5. So overall will be 5. Divided by
5.
what is
1.
the
This
resistance you are getting?
1.
1 by 2 plus 1 by 4 plus 1 by 8
5.
plus 1 by 16 plus 1 by 32. This is your resistance. Okay, so put the value in a calculator. So see, if you are putting the value of in a calculator, now I will show you. Just wait.
31 by 32.
31 by 32. So you are getting 5.
5 into 32 by 31.
5 into 32 by 31. So you are getting the value 5 into 32 by 31. Okay. Okay. So just wait. 5 into 32 by 31. So this is your VTH value. 5 into 32 by
VTH.
31. And RTH value will be 31 by 32.
160.
31 by 32.
31 by 32.
So okay, you got the value of a VTH and RTH. So you have the value of VTH, that is 5 into 32 by 31, and RTH value is 31 by 32. And you need to find the current across 64 ohm. Now just do the calculation, simple calculation. I will be 5
I
into
equal to V by R.
32 by 31 divided by 64 plus 31.
64 plus 31 by 32.
So how much you will get?
160 by 32 plus 31. 0.079.
0.079. This is the correct answer. Okay, understood? So this was the story of Milliman's theorem. So everyone, I hope you guys understood this. Now there is a two more theorem, that is substitution theorem, and another is compensation theorem. Okay, so no, we have so these are a very small topic, very small topic. Okay, so write the next heading, substitution theorem. Write it down. Any branch in a network may be substituted by different branch without disturbing the voltage, without disturbing the voltage and current. Okay, okay, so any branch in a network may be substituted by different branch without disturbing the voltage and current in the initial network provided in the initial network provided branch has the same set of terminal voltage and current as the original branch. So what it is, I will show you. See, if you have this is your resistor of a 4 ohm. Suppose this particular it has a 10 volt. Okay, and suppose this is your 6 ohm. So if you'll apply the voltage division rule, what the voltage you will get across this? 10 into 4 divided by 10, 4 volt. And what the voltage you will get across this 6 ohm? 10 into 6 divided by 10, that is 6 volt. Okay. So, and what is the overall current we are getting in this? 10 by 10, 1 ampere. Okay. So what I am telling, we can make it like this. This circuit is same 10 volt. We can make this circuit like this. This is your, so we can replace this 6 ohm with 6 volt. We are not disturbing the voltage and current. So what it's written, we are not disturbing the voltage and current as the original branch. We can replace this 4 ohm. We can replace this 4 ohm. Let it be 4 ohm. 1 ampere current will flow. Huh. As a we can make this as a 6 volt. Instead of 6 ohm, we can make this at a 6 ohm, and which have a current of 1 ampere. This can be one representation, and the another representation will be, we can do like this also. This is my positive negative 10 volt. I am getting a 1 ampere current in my circuit. This is my 4 ohm, this positive negative as 4 volt, and I can make this as a current source of 1 ampere, which having a voltage of positive negative 6 volt. Okay, we can make it like this. Is this clear, guys? So this was the substitution theorem. So this 4 ohm can, and we can do like this also. Positive negative 10 volt. This is positive negative 4 volt. This positive negative 6 volt, which having a current of 1 ampere. We can do like this also. Positive negative 10 volt. This is my 6 ohm resistor, and I can make this as a 1 ampere current. This is my, if you are assuming here positive negative, this is your positive negative, so you have to assume minus 4 volt. Okay, because means if I am assuming like this, or you can make it, or you can assume like this also directly. Assume here as a positive or negative as a 4 volt. It's up to you. Okay, guys, is this clear, Prasanna?
Yeah.
So this was the substitution theorem. Now the next theorem is compensation theorem. Compensation theorem. This is your compensation theorem. So what is the meaning of a compensation theorem actually? So basically the compensation theorem we use for the study of errors. Suppose you have some Z1 and this is your I1, EZ1, and this is your voltage, it's positive negative, that is E1 dash. This is your EZ, Z2, and this particular is z plus z delta ez. This is particular I, and this you are getting the current of I2. This is I1, let it be I1 only. Okay, now what I am saying, so this is particular my network. Okay, okay, this is my voltage, this is my z1, this is I1, this is z2 I2, and this is z plus delta z. Some changes is there, delta z, particular delta z. Okay, so suppose I am getting some error in this particular circuit. I am getting some error. Just wait for a minute. This is not as much important, so just suppose I having a circuit V, and here I am getting some I1 dash current. Okay, this is my Z1, this particular is my Z2, and this is I2 dash. Here I am getting some Z plus delta Z. I am getting some I dash current. This is my I2 dash current, this is my I dash current, and here I had assumed some different voltage. Okay, at different voltage I am getting this I1 dash, I2 dash, I dash. Okay, what you have to do, you just have to do these particular things as a short circuit. No, we are not getting questions from this theorems and all, this particular compensation theorem. So I'm just giving you some brief idea. Okay, and this I am assuming my delta I2 now, Z2, and this Z plus delta Z, and I had assumed some voltage here. Okay, this now this current I am assuming in this particular direction, delta I, and this plus minus I am assuming I delta Z. Why? Because of this delta Z I am getting some current. So this is means a small amount of fluctuation current. Okay, this is a very small amount of fluctuation current. It's a very small amount of fluctuation currents. It's not important, just note it down, one note where we use these things. Just remember this part only. Compensation theorem can be used to determine the steady state error. The steady state error. Okay, introduced by measuring instruments, and to obtain the null deflection in the galvanometer of a bridge circuit. In the galvanometer in the bridge So, okay. So what is means what I wants to say you. Uh, Actually, what's happening now? See, this is my voltage. This is my impedance. This particular is my impedance. If I introduce some ammeter here, so ammeter will not show the exact current. There will be some deviations, delta I deviations, means small changes of deviations, because of the ammeter will also what it will take some voltage. So that's why we use compensation theorem. So what kind of a error was, so this delta, what is the meaning of this delta? It's a error, because means if you are using a ammeter na, so ammeter will have some resistance, that resistance is getting added in this, that is represented by this delta z. Okay, it's very simple. Okay, so for getting the exact results, what we did, for getting the exact result, what we do, we just short circuited this path. Okay, we just short circuited this path, and we introduce the same amount of voltage what the error was coming because of the instrument. And by using these things we'll see this in a measurement and instrumentations in a very deep. So here just you have to remember, you don't have to remember these particular things, you just remember the compensation theorem can be used to determine the steady state error. That you just remember this part only. Okay, because of the measuring instrument will get some error. So you need to remember this particular thing only, and we'll see this in a very deep in measurement and instrumentation. Okay, now the next theorem is Telegan's theorem. Write it down, Telegan's theorem. Or we'll start this Telegan theorem tomorrow, because two theorem is only left, Telegan's theorem and maximum power transform theorem. So tomorrow we'll finish our theorems chapter. Okay, so tomorrow the theorems chapter will be completed, and we'll go for steady state and means transient. Transient is a very interesting topic of a network. Okay, means in a transient now what is happening, you will understand the role of capacitor and inductor. Like, I'm just giving you a brief idea. This is inductor, this particular is a capacitor, the switch is like this, it's moving. Okay, it's having some potential, some DC voltage, 5 volt. This is my 5 ohm. Okay, when switch is off, when switch is on, you need to find the current, and this is a very interesting part of the network. Okay, you will enjoy this particular uh, chapter, the transient. So it's a very interesting part. You will understand the actual role of capacitor and inductor, why the capacitor and inductors are very useful. Okay, guys, and maximum power transfer theorem will finish tomorrow. And I think maximum power transfer theorem, every year they are asking a questions around 4 marks from network. So maximum power transfer theorem, it's very important, and we'll move for the transient. So only like 20% part of the network is remaining. We had completed our network up to 80%, so 20% is remaining. So it's going to be complete within 7 classes. Yeah, within 7 classes it will be, I think it will be completed in 7 classes. And after that we'll take 4 or 5 classes for numericals, solutions of all gate problems. And other ways means like I'd solve all the numericals, means all the important numericals with the chapter only, but we'll solve that made easy workbook problems. So all the things will be completed. So yeah, I think after 10 days we'll move to the another subject, new subject, that is we'll go for the signal and system. Okay, so good night guys, we'll meet tomorrow.
Good night.